Hey guys, so this is 7.5, a little introduction to what we're really talking about and some of the key ideas that we need to understand. When we're dealing with logarithms, there are four principles or four laws that we have to understand in order to manipulate them and maybe use a calculator to help us out along the way. So the first thing we need to understand is when we are talking about expanding, okay, or contracting logarithms. Okay, and there are some rules that we can use when we talk about expanding or contracting a logarithm. And what that really means is we're going to take the logarithm and we're going to pull its constituent pieces apart. So if we look at a logarithm that might look very complicated, we'll say base 10 just to make it easy to write. So log base 10 of x times y. So we have a logarithm with two things being multiplied. Now it can be x times y, but it could also be just two numbers multiplied together. We have found that it is the same thing as the log of x plus the log of y. That is to say that multiplication between terms creates addition between logarithms. Now fundamentally it has to do with this principal idea that when we're manipulating multiplication problems like x squared times x cubed, we know that when we work with these, we're going to add the exponents to create x to the fifth. If you remember from before, a logarithm is equal to an exponent. So a logarithm really is an exponent. So it should make sense that multiplication internally would equate to addition between those logarithms or between those exponents. So similar principle there. Let's keep going and let's talk about our next rule. It's very similar in nature, but has a small adjustment. So there's rule number one. Rule number two says that the log of x divided by y, okay, so instead of multiplying, we're dividing, is the same thing as the log of x minus the log of y. Now I want to be careful here. It is true that division creates the subtraction as we come out. That is the connection. However, what I really want to focus on is not division in general, but the word denominator. Okay? It's not so much that it was division, it's that it came from the denominator, and therefore we subtract between those logarithms. Why that matters is when you have more than one thing in the denominator of a logarithms problem, you're going to have more than one subtraction. One of the things that confuses people sometimes is when we look at something like log of x over y times z. Because y and z are being multiplied, we would feel like we should add them. But they're both in the denominator of the fraction. That is, they're both dividing x. And so both of them should be subtraction. This could look something like log of x plus minus. Imagine that's a minus log of y minus log of z. So imagine they're both minuses. Or we could say log of x minus parentheses log of y plus log of z. We can say that it's addition between them when we acknowledge that the whole group is subtracted. For the most part, guys, you're going to want to stick with this upper idea that everything from the denominator is subtraction, everything from the numerator is addition. And then our last rule that we need to learn from this group is what do you do with exponents? So let's say that I have the log of x cubed. Then that would be the same thing as 3 times the log of x. And this is where we have to be careful to make sure our log doesn't look like a 1. It starts the word, because then we get a 31 idea in there. Don't want that. So log of, and essentially what we're saying is this exponent can drop down and fill this coefficient position. So those are our three rules. Now, coincidentally, they can be reversed. If you ever come across a problem that says 4 times the log of x, you can say that that's the same as the log of x to the 4th power. Okay, so we can go back and forth with this, and that's the idea of expand and contract, or expand or contract. All right, there's one last rule that we need to understand. It has to do with using our calculators to help us with logarithms. We know in our calculators, they're very fancy, they're very helpful, but they traditionally only have this log button that forces us to use log base 10 or We can use ln, which is log base e, but neither of them gives us the options to do other bases. Well, it turns out that when we take the log, say base 4 of 7 or something like this, we can use what's called the change of base formula, which tells me that it is equivalent to the log base 10 of 7 divided by the log base 10 of 4. Now the reason why it matters that it's base 10 is that these can now go into the calculator just the way they are. I don't have to do anything fancy to them. And so I can go in and take the log of the top, which is 7, and divide it by the log of the bottom, or the base, which is 4. And I get 1.4036. Now remember, if we remember what a logarithm is, that's what the exponent is that turns the base into the parentheses. So if I take 4 and raise it to that exponent, I should get 7, which I do. Okay. So that being said, now that we've figured that out, TI, Texas Instruments, and many other calculator producers, or manufacturers, have created a different software option. This is not going to save you time or steps, but it's there, and some people really like it. If you hit this math button and you scroll up a couple, there's a term called log base. And if I hit that log base, I can put my subscript 4 in, and then put my 7 in. So here I don't have to make it look a certain way. I can just type it in the way that it looks in the book, and I get the exact same answer. So if you like that and you have a Texas Instruments device with you, that can save you the headache of making it look a certain way, but really it doesn't save you any keystrokes, the same amount of typing. So it doesn't necessarily save you any time, but you get that 1.404 and you're done. Okay? So it gives us the ability to approximate these values pretty quickly. So, all right, good luck. We'll see you in class. Let me know if you have any questions.